Hello, everybody. Let us explore the civil engineering design process. The civil engineering design process is made up of several steps that the civil engineer will follow in order to come up with a workable solution to a problem. In civil engineering, more often than not, a workable solution involves the design and construction of infrastructure such as roads, power plants, reservoirs. The workable solution could also be an office building or even someone's home. The facility that is part of the engineer's solution must meet certain criteria, such as seismic design criteria, structural design criteria, a city code, a fire code, or an environmental criteria. Also, the facility must accomplish certain tasks that the proponents wanted to accomplish. The diagram shows the steps of the engineering design process that I personally follow on the projects that I work on. It is important to note that engineers do not always follow the engineering design process steps as are presented here. It is very common for an engineer to select an alternative, check to see if that alternative meets the requirements and constraints, and see if that alternative solves the actual problem, and if not, go back to an earlier step to make modifications or to completely change the selected alternative. The process of selecting an alternative, checking to see if it meets the criteria, and then going back to make changes is called an iteration. Some projects require many iterations before an alternative is selected. This alternative process is indicated with the dashed arrows on the slide in front of you. Let us take a look at each of the steps that make the civil engineering design process. The first step is defining the problem. It is my experience that this part of the design process is the hardest part. During this first step, the engineers should be prepared to investigate and understand the problem thoroughly. The engineer should be asking questions like, what is the problem? What is the need for a solution? Why is it a problem? Who does this problem affect? And who benefits from a solution? Engineers learn from the experience of others. This is why the next step allows the engineer time to check and see if existing solutions to similar problems exist. This is important because an engineer can also look at the lessons learned by others trying to solve similar problems, so he or she does not have to spend time on solutions that will not work. Checking on what was done by others can spare the engineer from repeating mistakes that others have already made. When going through the second step of the process, it is important for an engineer to interview owners and operators of similar projects to gain an insight of how the project met their needs and what improvements they would have liked to see. The third step in the civil engineering process is to identify the problem's constraints. Constraints are conditions that need to happen before a project can be completed, and before a project can be successful. Constraints help narrow choices when creating a project. Design constraints can feel like a negative thing sometimes, but they help shape the project to fit the exact needs of the client. Constraints are factors that limit the range of potential solutions that can be adopted. In the early stages of a project, only some of these constraints may be known, while others become apparent as the design of the project progresses. There are two types of constraints to be considered: technical constraints and non-technical constraints. We will discuss constraints in a separate presentation. The fourth step of the engineering design process is brainstorming. Usually, design problems have many good possibilities that can provide the engineer with a solution to the problem. As a matter of fact, if I ask 10 civil engineers to design a road from Las Vegas to San Francisco, I will probably get 10 workable solutions. And chances are that none of them are exactly the same. In civil engineering, we look at all possible solutions or alternatives before settling on one. A good engineer or a good designer will look at as many alternatives as possible before arriving at a solution. In step 5 of the design process, an engineer will take all the information and ideas gathered in the previous 4 steps and develop as many alternatives as possible that can potentially solve the problem. The engineer will also create a list of advantages and disadvantages for each one of the brainstormed alternatives. In many projects, the preliminary design of the project starts during this stage. In step 6 of the engineering design process, the engineer decides if each of the alternatives identified meets the criteria, and the engineer rejects the ones that do not. Preliminary design continues during this stage. Also, the engineer studies the advantages and disadvantages of each of the identified alternatives and selects the alternative or solution that solves the problem and meet the client's needs. In step 7, the engineer continues developing the selected alternative. And this is where the design of the project takes place. In this step, the engineer refines and improves the alternative and starts including details in the design that were not considered prior to this point in the alternative selection process and in the preliminary design process. At this stage, if the engineer encounters issues or problems with the alternative, he or she can go back to revisit previous steps in the process. Iterative design is a process of designing a project in which the alternative and/or design is tested and evaluated repeatedly at the different stages of the process to eliminate any flaws that the design is before the design is finalized and the project goes to final design and then construction. In other words, iterative design is a process of improving and polishing the design over time. This iterative process will help arrive at the best solution possible for a problem. The final step, in this case step 8, is to present the problem to the client and get their input. I usually engage my clients throughout the process, but take the opportunity to fully vet the project with them at this stage and prior to completing final design and prior to sending the project to construction. This is it for the civil engineering design process. I will see you guys in the next video.